two formulas. Two formulas you need to know. One of them is the basic exponential growth formula. Do you guys remember what that one looks like? Whoops.
So we're gonna have to memorize R.
Yeah, probably. They're almost identical though. They're almost the same thing. Yeah. So this is like if you have some number and it grows 3% for 5 years, that's what you use. Okay. It's just exponential growth, or it could be decay. If it shrinks by 5%, you use like a minus 5% right there. Okay. The other one is called compound interest. So this only applies to money and interest, and it will use the word compound in the problem. Like if Jim invests $10,000 compounded monthly at 12% interest, that kind of thing. So it's almost the same, except for what changes?
1 plus R over K.
R over K
KT.
to the KT. So there's a couple Ks I get it added on. Where K stands for the number of times it's compounded per year. So if it's monthly, K is 12, for example. That's what we did like on, I think it was like 17 through 19 on the last assignment. Okay. And like on 50, you should use this formula. Did you guys all do that yesterday? Or those of you who have done 50? Yeah. Okay. So on number 1, these are just exponential growth or decay problems. Does this function represent growth or decay? Growth. How can we tell it's growth?
It's 1.
Because it's 1 plus 0.3. Basically, if what's in parentheses is bigger than 1, it's going to grow. Because if you multiply by a number bigger than 1, it's growth. If the number that's in parentheses simplifies to less than 1, it's going to decay. When you multiply by a value less than 1, the number gets smaller. Okay, so number 1, A is growth. What is the initial value? 1200. Okay, you guys see how easy this is. What is the rate of growth or the rate of decay? Okay, 0.3 is what as a percentage? 30%. You got to move the decimal twice. So 0.3, 1, 2, 30%. Some of you might have a button on the calculator that turns into a percent, but anyway, it's kind of basic. Number 3, is that growth or decay? Growth, because 1.25, maybe I should have done 2 instead. 1.25 is bigger than 1. What's the initial value? 100. What is the rate of growth? 25%. Because it's 0.25 bigger than 1. They must have added the 25% already. So it's 25%. So on number 1, they did not simplify the parentheses. On number 3, it's more common. They already did simplify the parentheses. Let's do number 4, and then we'll jump to the back. Is number 4 growth or decay? Is 4 growth or decay? It's decay because 0.65 is less than 1. Initial value, 55.75. What is the rate of growth or decay? Okay, it's 35%. Sometimes they just say 35% decay, or sometimes they say negative 35%. I want you guys to go ahead and say negative 35%. Does anybody not know how we got the negative 35%? Well, I'm going to explain it as if somebody didn't get it. Okay, so the way that we got it is, in the parentheses, 1 plus the rate of growth or decay should equal that. So what do we add to 1 to turn it into 0.65, or what do we subtract in this case? If you subtract the 1, like you're solving for R, you get R equals negative 0.35. So it's a 35% drop. All right, so on the back side, we got to write the function ourselves. We have to write. I'm just going to use y equals, I guess. Number 9, a, y equals. All right. So the charity had an attendance of 500. Where's the 500 go? Right at the start. And in parentheses, it's going to increase by 5% each year. So what is 5% as a decimal? 0.05. Got to move the decimal twice. Invisible decimal's at the end of the number, so when you move it twice. So instead of putting 1 plus 0.05, let's just put 1.05. And then, does it say how many years? No. So you just put a T right there, because we don't know how many years yet. And then for B, it says how many people will be there after 10 years. So you just plug in 10 for the time. And what might be a good place to round this to? If we're talking about people, maybe the ones place. Oh yeah, it says round your answer to the nearest person. So that would be the ones place. Let's do a decrease one. Where's that start? Number 13. Looks like 9 through 12 are all increase and 13 through 16 are all decrease. Okay, so on 13, it says the yearly profits of a company is $25,000. That is not a lot of profit. Okay, the profits have been decreasing by 6%. So how do we make it decrease by 6%?
1 minus 0.06.
Right, oops. 1 minus 0.06. So basically if something is dropping by 6%, it's only going to be 94% of what it was. So anyways, if we simplify the parentheses, it's 94%. So on those 13 through the bottom, make sure you're subtracting the percentage. And then for the B, oh, what did 9B come out to? Did anybody plug it in? 814. Anybody concur?
Yeah.
Okay. 13B, it says, what will the profits be in 8 years, round to the nearest dollar? So that means we're still rounding to the ones place. Let's say 8 years, is that what it said? Yeah. Okay, the last page, that's the hardest one. There's more not like this. Number 14. Okay. Directions kind of got cut off, but you can kind of tell what it is by looking at the bottom part. We're supposed to find the inverse function. That's 13, isn't it? Oh, whoa. 13. All right. Huh? Oh, what could you do? So, how do we find the inverse function? How did we do that? switch the x and y. So this will be 7y plus 18 over 2. That's basically what inverse means, the variables switch places. So the g of x is like the y, so it becomes the x. And then we got to solve this for y. So how would I solve this for y?
Times 2.
Right. If the whole side is divided by 2, you can times 2 to fix it. So it's 2x equals, those cancel out, 7y plus 18. Then what?
Minus 18.
Try to get y by itself. Does 2x minus 18 x? No. And then divide by 7. Now, you could just put the whole side divided by 7, kind of like what we started with. If we were graphing, which we're going to do later, you'd probably want to divide each of those individually by 7 so that you can see the slope and the y-intercept. But I do want you guys to change it back into function notation. Hmm. 15 looks much easier. Actually, looks like 13 was the hardest of the bunch. Alright, I'll do it anyway though. 15. So it becomes x equals negative y, come on now, plus 3. So to get y by itself, I'm going to subtract 3. And to get rid of the negative, I'm going to divide by negative 1. What happens when we divide by negative 1? Everything switches. So it's negative x plus 3 now. So f inverse equals negative x plus 3. Well, look at that. It's the same thing. That happens when you get a negative 1 slope. They're identical. If it's a line, it's a linear function. Okay, 17. Kind of the same thing, but this time we got to graph them both. What would the graph of that f of x equals negative 1, that thing, what would the graph look like? It'd be a line. How can we tell? Because it just has an x. So this is like the slope and the y-intercept, right? They wrote it in unconventional order. But let's save the graphing for last. We need to find the inverse. So how do I get y by itself here? Get rid of the plus or minus number first. I'm going to add 1. So x plus 1. Okay, I think we had one of these on the last assignment. I think this kind of confused us. How do I get rid of the negative 1/5? Divide, but how do we divide by negative 1/5? Multiply by the reciprocal. This goes back to like 7th grade, 6th grade. When you divide a fraction, you flip and multiply. So really what we need to do is multiply by negative 5.
That's what helps. I literally said that.
It was wrong when you said it. I just kind of tune hope out. So. Okay, so the whole side just gets multiplied by negative 5. So yeah, I would go ahead and distribute that. So it's f inverse equals negative 5x minus 5.
Is the test Thursday?
Nah, I'm going to save it for Friday. I'm trying to pick off like concepts that I'm just trying to go over these couple concepts again so we'll feel a little better.
I do not like you as a person.
How are you gonna do it without doing work? Tell me that. Okay, I already told you, if you have to do it, do any work, then I expect you to not erase it. I don't care if it makes your page messy. Don't care at all. Oh yeah, we're supposed to graph these too. Okay, yeah, we kind of already mentioned it, but these are lines, right? So where am I going to start the graph for this -1? The number in front of the x is the the slope. Usually it's written in opposite order, like the x usually is in front, but in this case, it's not. So the -1 is the y-intercept. Yeah, mine's going to be a little sloppy because I'm not on graph paper. And the slope is -1/5, which means what? Down 1, right 5, yes. Down 1, right 5, or up 1, back 5. So it looks like that. Where am I going to start this one? -5, 2, 3, 4, 5. And I'm going to go down 5, right 1, but since that's off my graph, I'm going to go backwards. Up 5, left 1. Up 5, left 1. If you do it right, it should look like a reflection. Oh. No. Over the line, y equals x. Fold it over, it looks the same. Okay. By the way, if you did not finish 379, I want you, after this, like we're almost done here, I want you to do that first. So if you have any questions. Yeah.
What are you talking about? 379?
The book assignment, if you haven't finished that, I want you to prioritize that one. That one will be due tomorrow. This one, I might give you another day. It should, I don't know, that's not that hard anyway. Except for maybe this last part. -2x cubed plus 1. I think on the homework we only had x squareds, but this is actually kind of, it's not that bad.
Shh. Go back to where you came from. It's not racist.
Where did you come from?
I don't know. Why did you do this?
Kind of Germany.
My ancestors came from Wales, but they all drowned.
Then how are you here?
Because one survived as a child. Very unlucky child.
Okay.
His parents died. He's Batman. He became Batman. That child is
There.
Everything except for Batman.
You now know that child. Okay. So, we're going to try to get y by itself.
Except if you spill the tea, it gets shanked.
Alright, what should I do at this point?
Square, cube root. Divide by -2.
Yeah, I guess I'll just put it like that. Yeah, it's kind of a mess. Alright, so I got y cubed equals this stuff. If you divide the negative, I'm going to go ahead and put that on top. Put the negative on top. So that becomes negative, that becomes positive. Alright, how do I get rid of the cube? Cube root. Alright, actually, yeah, let's get over there. Okay, it's not simplified if you have a radical in the denominator. Basically, this is like cube root of 2 in the denominator. And how do we fix it if there's a cube root in the denominator? What's the number that 2 goes into that actually does have a cube root? 8. So what I'm going to do, most of us never mastered this back in chapter 2 ago, is multiply the top and bottom by cube root of 4. Because that will make the bottom cube root of 8. And what is the cube root of 8?
2.
2. So now we have no more cube root in the denominator. On the top, that's basically distributive property. So it's cube root of negative 4x plus 4. What is this? F inverse. Remember when we did the square root thing, how we had to use a plus or minus? Well, that doesn't apply to cube roots because they work with negatives better. Alright, anyways, I'm finally done with that. Now, how are we going to graph this bad boy?
Right question.
Now, if we normally don't know what a graph looks like, how do we figure it out?
Scroll down real quick again.
If we normally don't know what a graph looks like, how do we figure it out? Yeah, make a table, make up some x's, see what it looks like. So let's just try like maybe, the standard 5. Yeah, this is gonna get too big too quick. But if I plug in negative 2 cubed is negative 8 times negative 2 is 16 plus 1. Okay, that probably won't fit on our graph very well, so we're gonna have to probably throw that one out. But if I plug in negative 1 cubed is negative 1 times negative 2 is 2 plus 1. That should fit on our graph. If I plug in 0, that's 0 plus 1. If I plug in 1, that's negative 2 plus 1. And if I plug in 2, it's something giant again, so it's not going to fit. That'd be negative 16 plus 1 would be like negative 3. Okay, so really only the middle 3 are going to squeeze in there. So negative 1, 3, 0, 1, 1, negative 1. Okay, you might not know what's going on, but it's basically, they get really big after that and are really small, so it just looks like that. Okay, when we graphed the inverse, we cheated. How did we cheat? Well, I didn't make a table. What did I do? We flipped the x and y values. So instead of negative 1, 3, the inverse should have 3, negative 1. Instead of 0, 1, the inverse should have 1, 0. And instead of 1, negative 1, the inverse should have negative 1, 1. Okay, let's see if I can do this maybe. Oh. Again, it should be a reflection.